Welcome to VW 3.1. Today we're going to be covering the distance formula. So the formula itself you might have learned already, but we're going to review it. D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Some people switch these around, like x2 minus x1. Doesn't really matter. Or some people refer to this as delta x squared plus delta y squared, like that. And in physics or science, the triangle just means change. And again, we say that delta. But the main thing I want you to know today is that this actually comes directly from the Pythagorean theorem. So I'll show you that today. So first, let's try an example here. Find the distance between the points -4, 5, and 3, 2. So if you know this formula, you really could just plug it in and work it out. So I'll show you the mechanics of it first. We have D is equal to the square root -4 minus 3 squared plus 5 minus 2 squared. Keep going. That's going to be -7 squared plus 3 squared. That's 49 plus 9, which is the root of 58. And there it is. I'm going to show you where this really comes from by plotting it. So let's plot -4, 5. That would be right here. And then let's plot 3, 2. That'd be right here. We make a line connecting them. And the question would be, well, how long is that line? So in geometry, you probably went over this already. We can simply make a triangle. And we're going to make a right triangle like that. Because by making a right triangle, we can use a Pythagorean theorem. And to figure out how long these legs are, we can count or just subtract. We see this is 5 and this is 2, so this must be 3. We see this is 3, that's -4. That means that leg is 7. So notice how you can also do this formula in your head intuitively by just thinking about what's happening on the graph. And now if we do Pythagorean theorem, we can let that be x and write 3 squared plus 7 squared. That's x squared. So 9 plus 49 is x squared. X squared is 58. And notice how we get the exact same answer. So now let's try this formula on a little harder example. There are 3 points given. Let's plot them. We have -2, 1, 2, 3, and 3, 1. Let's connect all of these. And we're doing that because it says plot each point, and it makes a triangle, which we have. So A is done. B, find the length of each side of the triangle. So notice how for a question like this, you could just crank out the algebra, plugging this formula in 3 times, but if you have this picture, I think it's better if we just do it using our geometry skills here. This bottom one we know is 5, and on the other ones, let's just make right triangles, like that. So essentially we're going to make a rectangle. Here's your right angles. This is 1, 2. Do the Pythagorean theorem in your head, that should be the root of 5. This is 2 and 4. So again, do the Pythagorean theorem in your head. This is root 20. We'll reduce that later. For now, leave it as root 20. Now let's write the answer. So we have the length from A to B, so I'll put AB with a line over it. The length from A to B, and I'll label it to make it more clear. This would be 2 root 5, or root 20. And then the length from B to C is going to be root 5. And the length from A to C, that's going to be 5. So notice how quick that was if you just do the Pythagorean theorem and use what you learned last year. Now part C, show that it is a right triangle. So to do that, we're going to use a Pythagorean theorem. First, highlight this one. Notice that's the longest leg, which means if it is a right triangle, that must be your hypotenuse. So we plug it in, your Pythagorean theorem, and let's check. 5 squared is equal to root 20 squared plus root 5 squared. And we're going to see if this works. 25 is equal to 20 plus 5. 25 is in fact 25. So it checked out. So since the Pythagorean theorem works, our therefore is ABC is a right triangle. Because the Pythagorean theorem can only work on right triangles. And then the final part is part D, find the area. So let's just recall the area formula, 1/2 base times height. So half, your base is right here, because now we know the right angle is right here. So 1/2 root 5 times 2 root 5. Your 2's cancel, and our answer is 5. Now the final concept today is going to be midpoint. So notice how it says finding the midpoint of a line segment. So to show you just what we're doing, draw a line segment right here. Let's call the endpoints A and B. The midpoint is simply the point in the middle. That's your midpoint. And it cuts it in half perfectly. So that's the basic idea. To do this, we have a very nice formula. And I'll show you how it works right now. The midpoint formula is simply x1 plus x2 over 2, y1 plus y2 over 2. Or if you just think about conceptually, you just average the 2 points. So again, if I'm showing you mechanically, it's quite simple. The midpoint, that's going to be -5 plus 3 over 2. You just take your x pieces right there, comma. Now take the y pieces, 5 plus 1 over 2, and reduce it. So this would be -1, comma 3. Now to understand it, let's actually plot it again. -5, 5 is right here. 3, 1 is right here. I'll connect it. And notice how it is completely accurate. -1, 3, we can kind of eyeball it. There's your midpoint. So essentially the formula is averaging the x coordinates to get this piece, and it's averaging the y coordinates to get the horizontal component. And that's all there is to it. So for this last one, let's do this really quick. We'll find the midpoint. We'll just do -2 plus 2 over 2, 0 plus 4 over 2. Our answer is 0, 2. Okay, so good luck on the rest of the problems and bring your questions to class.